ECG machine records the electrical changes on moving paper at 25 millimeter per second. So the ECG machine will be recording the electrical changes that occur on the heartbeat, that occur on the electrical impulse or the electricity of the heartbeat at the rate of 25 millimeter per second. So the paper will be moving at the rate of the 25 millimeter of second, and our heart and according to the heartbeat, according to the electricity of the heartbeat, the paper will be measuring the ECG on that basis. So on the ECG paper, if we see that, then the 1 second will comprise of 25 millimeter. As you can see, the ECG paper will be moving at the rate of 25 millimeter per second. So 1 second will comprise of the 25 millimeter of the box. So there will be the 1, 2, 3, 4, 5 large box and the 25 small box. So in this way, there will be the 1, 2, 3, 4, 5 large box, and there will be the 5 small square box in one. So the total will consist of the 25 small box. So as the 25 small box will measure 1 second, then the one large square box will show 0.2 second, and one small will show 0.04 second. So if we convert that in millisecond, 0.2 second will measure 200 millisecond, and 0.04 second will measure 40 millisecond. So this small box will represent 0.2 second or 200 millisecond, while this further small box will measure 40 millisecond, 200 millisecond, and this is 1 second. So 1 second will show 5 bucks, 2 second will show 10 bucks, 5 second 25 bucks, 10 second will show 50 bucks, and the 60 second, that is which is 1 minute, will show 300 bucks. So while calculating the heart rate means beats per minute, then we will see the 300 bucks. And if we see that, if QRX complex per 1 box, if we see in this 1 box, if we see 1 QRX complex, then 2, 3, 4, 5. So in 1 second there will be the 5 heartbeat, and if that occurs in per 1 box, there will be the 1 QRX, then that will mean that it will have 300 heartbeat, 300 QRX in a minute. So this is like this: in 1 box, 1 hour, 1 hour, 1 hour, 1 hour, 1 hour, then that will measure 300, because it will, in the 1 minute, it will comprise of 300 bucks, and we have 1 QRX complex in 1, means that will have 300 heartbeat. But what if in 2 bucks that will arise 1 QRX complex, and we can see that we can compare that 1 QRX in the RR interval. So if the RR interval shows the 2 bucks, that which literally means that the 2 bucks will have 1 QRX, then that will be the half of the previous one, as you can see this. So there will be less heart rate. So that will show heart rate 300 beats per minute if 300 QRX, if 1 QRX in a box. Then what if 1 QRX in 2 bucks, then that will be 300 QRX divided by 2, 150. So if there is 1 QRX in 5 bucks, then that is 300 by QRX, which is 60 beats per minute. So in this way we can calculate the number of R in this. If there is what is the number of the box, we have a large box, then we can divide it and make the calculation of the heart rate. And similarly, if we go and see the PQRXTU, if you see the wave PQRST, then this will be the beginning, this will be the ending of the P wave. So this will mean that is the atrial depolarization and the atrial contraction. Beginning of the P wave, as a node will have the impulse, then it ends here, then this denotes the AV delay, and here it starts the AV node. And the QRS will denote the depolarization of the ventricle, and the repolarization of the atrium is hidden over here, because the mass of the ventricle is more than that of the atrium. While the ST segment shows the contraction of the ventricle, and this shows the repolarization. This shows the repolarization of the ventricle. So for the atrium, it will have the P depolarization, showing depolarization and contraction of the atrium, and the repolarization will be hidden in the QRX. And for the ventricle, the QRX will show the depolarization, ST segment will show the contraction and the repolarization by the T wave. So you can make a mnemonic for the segment and the interval. So the segment means the segment where it stays in the isoelectric line, so there will be no deflection in the segment. When there is the term segment, it means in the isoelectric line, so there will be the ST segment, end of the S and the beginning of the T, so ST segment, isoelectric line, ST. And then we have two interval, PR interval and QT interval. It would have been better if it had been named as PQ, but I don't know why it is named PR, but it shows the suru suru, and here the suru on there. Suru suru means the beginning of the P wave suru and the beginning of the QRX. So suru PR interval, and the suru on the beginning of the QRX complex and the ending of the T wave. So this is also the QT interval. And you can see the suru of SA node excitement, the suru AV node excitement summa. So this shows the beginning of the atrial depolarization to the beginning of the ventricular depolarization. This shows the PR interval. And the term and the time, the average time for this is the 120 second to 220 second, which means 3 to 5 small square bucks. 3 to 5 small square bucks is the average. And so if that is short, then it will mean the atrium depolarization is very close to the AV node, or there is abnormal fast conduction if we have smaller than 120 millisecond. If the PR interval is less than 3 bucks, then that will show the certain PR interval. And we have to make the calibration of ECG. ECG, as the 1 millivolt is equal to the 1 centimeter. That means the 2 small square box, as the 1 consists of the 5 millimeter, 10 millimeter, 1 centimeter. As the 2 large square box must be equivalent to 1 millivolt. So this is the thing for the PQRS segment.